The coming set of questions in the topic vectors from the chapter motion in a plane. Well, to be more precise, at least the coming 5 to 6 questions have, they sound purely mathematical, but underlying that mathematical solutions lies a very important physical concept. Okay, so we might want to go in detail to understand what the physical concept is. Why? Because the next year it might not be the numerical, instead the concept that defines the numerical. Okay, so it might take some additional time. So we'll divide it into solution and then into the concept. Okay, in 2 parts. I think a couple of questions have 3 parts for that matter. Okay. Now what do we have here? Vectors A and B are perpendicular when 3a plus 2b is equal to 7. We've been asked to find the value of a to b, the value of x when a to b is x by 2. So we have 2 vectors, vector A and vector B, in either ways of orientation. The angle between them is 90 degrees. Since vector A is perpendicular to vector B, theta is 90 degree, which means vector A dot vector B is magnitude of vector A times magnitude of vector B into cos theta. This product is equal to 0. So A dot B is AB cos theta. Theta is 90. Cos theta is cos 90. Cos 90 is 0. Therefore, A dot B is equal to 0. Now, most of us here might want to discuss more on this. How do we choose? How do we select to choose between A cross B and A dot B? See, these things come intuitively. But then, yes, it's also essential that we, to understand the difference between these two so that we understand how to use them and how to choose them. Right? Something that I have to discuss later. We just focus on the solution now. So we have A dot B is equal to 0. What is A dot B? Is vector A dot vector B, which is AI dot 2i, A into 2 times I into I, plus bj dot 3j, B into minus 3, plus 1k dot 4k, which is 1 into 4. I dot I, j dot j, k dot k is 1. Therefore, this becomes 2a minus 3b, 4. 2a minus 3b plus 4. But what is vector A dot B equal to? Vector A dot B equal to 0, which means we have 2a minus 3b plus 4 equal to 0, or 2a minus 3b equal to minus 4. Given to us that 3a plus 2b equal to 7, I'll multiply the first equation with 2 and get 4a minus 6b is equal to minus 8. Multiply the second equation with 3 to get 9a plus 6b equal to 21. And what I get is 4a minus 6b equal to minus 8, 9a plus 6b equal to 21. Adding these, minus 6b plus 6b is equal to 0, 9 plus 4 is 13a, 21 minus 8 is 13, a is equal to 1. And therefore, a by b is equal to x by 2 is equal to 1 by 2, which gives us the value of x equal to 1. Now, don't jump into the answer as x equal to 1 just by deriving a equal to 1. Why? Because it could be a equivalent fraction. So always make sure you go to the question well. A to b is x by 2. So a by b is x by 2, which is equal to 1 by 2. And therefore, x equal to 1. Okay? Right. So that's one part of the story. Now, okay, maybe let's discuss that as a second part. Oh, okay, we have enough time here. Maybe we can do that here. Okay, so what is a dot product? Now, I'm not going into the concept here. We're just going to the mathematical definitions of this. Okay. Why? Lots of questions coming up. So dot product is a number, which means it is a scalar product and is not a vector. It measures how much one vector helps another in the same direction. Think of it as an alignment or agreement between, well, these kind of things should be avoided. My bad. Please don't make a note of this. Think of it as an alignment between two directions, where A dot B is equal to mod A mod B cos theta. Now, real world meaning, when two people pull a rope in the same direction, they add up well. Big dot product. When they pull at 90 degree, they don't help each other. Dot product is 0. What does this mean? So it's basically this trying to tell you this. When two people pull a rope in the same direction, say let us replace this with a block of mass in the same direction, maybe say forces F1 and F2. In this case, what is the angle between F1 and F2? The angle between F1 and F2 is 0, and therefore F1 dot F2 here will be equal to vector F1 dot vector F2 will be equal to F1 into F2 times cos 0, which is 1, or this would be equal to F1 F2. Which means the product of the magnitude of both the vectors. Now, when they pull at 90 degrees, one person is pulling horizontally, the other is pulling vertically up, right? So we have two forces here. One, which is F1, acting only horizontally. And we have another force, F2, which is acting only vertically. In this case, the dot product of F1 and F2 is magnitude of F1 times magnitude of F2 times cos 90, which is 0. Therefore, the dot product is equal to 0, which means they don't help each other. Okay? Exactly like the one we had in this question. Now, what is a cross product? Okay, cross product. How much twisting or spinning force does two vectors create? And this is a new vector, not a number, unlike what? Unlike a scalar, which is a number, which is a scalar number. So think of this as the area or the rotation effect. Now, the rotation effect is something which is related to a most practical example that we often discuss is turning off a doorknob. Okay, let's not go into this cross product now. We have a lot of questions based on cross product, and we'll discuss back then. Now, coming to the coming to our interest here. What is our area of interest? How do we differentiate between the use of dot and cross product? If the vectors are perpendicular, usually we go for dot product. Why? Because dot is equal to 0 means theta is 90. If the vectors are parallel, we use cross product. Why? Because when theta is 0 or 90, cross product becomes 0. Projection or component in a direction will be dot product. If it is work, which is force cross displacement, it will be dot product. Area of a triangle would be cross product. Torque or anything with a rotational effect will be cross product. Now, motion in a plane, topic vectors, we have to focus in three topics here. Focus on three topics. One, if the vectors are perpendicular, dot product. Vectors are parallel, cross product. And if we are asked to find a vector which is perpendicular to two given vectors, not two perpendicular vectors. Instead, if we're asked to find a vector perpendicular to two given vectors, then again we use cross product. Now you don't want to, you might not write down these things. What we need is these three highlighted ones. Please make sure you make a note of this. Okay. Now, if you want, can make a note of this as well. Only if you feel that's important. Don't worry, each and every aspect here will be covered in the following questions. Okay, regarding area, the twist, the torque, and the area, the normal, all of these are coming in detail in the solutions that we have coming up next in the series. Okay. So yes, now let's move on to the next question. Okay, maybe you can pause this because the most important ones are these, right? The ones which are highlighted. So please do make a note of that.